This is the video for 2013 PHSS mid-year paper, Section B, Paper 3, Section B. Okay, the following procedures describe the preparation of hydrated crystals of copper 2 sulfate. Now this is obviously a salt preparation question. Copper 2 sulfate. Now, which method is it being used? Copper 2 sulfate is a soluble salt. Okay, so first thing you need to recognize is that copper 2 sulfate is a soluble salt. Is it a sparse salt? It is not a sparse salt, so it cannot be titration method. So it must be the first method, which is acid plus insoluble substance. Okay, so basically this is the salt preparation mind map, and it must be the first method, acid plus insoluble substance. And in this case, it's actually acid plus excess carbonate. Okay, add 1 spatula of copper 2 carbonate to 50 cm³ of dilute sulfuric acid. When it has reacted, add further amount of carbonate until no more dissolve. That means acid plus excess carbonate. The mixture is filtered. Filtrate is then heated to about half its volume and is allowed to cool slowly. The crystals are filtered off and are dried on the filter paper. Strong heating is not recommended. Explain the significance of the underlying phrases. Now, all the steps here are basically almost the same as the steps in the example in the mind map. For example, the first one, why you have to explain the significance of until no more dissolve. Now, why do we have to add acid? Or I should say, why do we have to add further amount of carbonate until no more dissolve, until no more of the copper 2 carbonate dissolve? Okay, so it's the same thing as here. Continue adding zinc until no more zinc dissolve. Why? So that all the sulfuric acid has reacted. So in this case, the answer should be to ensure that all the acid has completely reacted. Okay, so basically it's like that. You have a beaker. Okay, you add copper 2 carbonate, which is a solid, and then after that you add sulfuric acid. I should say you add copper 2 carbonate to dilute sulfuric acid. So this is H2SO4, and this solid is copper 2 carbonate CuCO3. Now when you add these two, when you add copper 2 carbonate to sulfuric acid, what are the products you get? This is carbonate and acid. So acid and carbonate, you should get salt, carbon dioxide, and water. Okay, so in the same beaker, you get salt, and the salt is copper 2 sulfate. Copper 2 sulfate, carbon dioxide, and water. And all these things will be in the same beaker. Now the reason that must add CuCO3 in excess is so that all the acid has completely reacted. Okay, there won't be a chemical reaction whereby you can calculate the exact amount of CuCO3 and sulfuric acid and then pour together. It's very difficult to do that. So in this case, we don't know what would be the amount that both would exactly reacted. Therefore, we add excess of this to sulfuric acid so that all the sulfuric acid would have reacted. Why do we have to make sure that all the sulfuric acid has reacted? It's so that the product that we get later, there won't be any sulfuric acid inside. Because what we want at the end is crystals of copper 2 sulfate. We don't want this crystal to have a bit of sulfuric acid. Okay? So until no more dissolve, the mixture is filtered. So this mixture is filtered is so that to remove the excess copper 2 carbonate, heated to about half its volume, is so that we want to obtain a saturated solution. Cool slowly so that crystallization will take place. Okay, cool slowly. Cool slowly. One more thing is so that bigger crystals will be obtained. Okay, so this one heated to about half its volume is so that a saturated solution can be obtained, and a crystallization can occur and allowed to cool slowly so that a bigger crystals can be obtained. Now write a balanced chemical equation including state symbols for this reaction. So that would be CuCO3 plus H2SO4, and then you get CuSO4 plus water plus CO2. Then after that you have to write the state symbol. CuCO3, is it soluble or not soluble? So all carbonates are not soluble. This is from the solubility table. All carbonates are not soluble except group 1 and ammonium. Okay, so you have to memorize by heart the solubility table. This is the solubility table. All carbonates are not soluble except group 1 and ammonium. So copper to sulfate, copper to carbonate is not soluble. And sulfuric acid, of course, is AQ. CuSO4, copper to sulfate, it is soluble because all sulfates are soluble except barium sulfate, calcium sulfate, and lead 2 sulfate. So this is AQ, this is liquid, this is gas. Okay, pardon me for my ugly handwriting. Now suggest another reagent which can react with dilute sulfuric acid to produce the same salt. So if we don't want copper 2 carbonate, what would be other substances? So you try to recall any reaction that involve acid and copper something. Cannot be acid and copper because copper doesn't react with acid. So another possibility would be copper 2 oxide. That means a base and an acid. So copper 2 oxide is one of them. Copper 2 hydroxide is also a base, is another one of them. That's why the answer is copper 2 oxide or copper 2 hydroxide. Because both are base and we know that base react with acid. Now the third one. Suggest the concentration of the acid used. No, if the concentration of the acid used is 0.5 mole per dm cube, determine the mass of copper 2 carbonate reacted. Now this is a typical mole concept question. Okay. Now, as in all mole concept question, you have to identify the 2 substances needed or mentioned in the question. One is copper 2 carbonate, the other one is acid. So in this case would be the sulfuric acid. So you have to write down sulfuric acid and copper 2 carbonate, CuCO3. What is the mole ratio? So the mole ratio must be based on the balanced chemical equation. So the mole ratio in this case is 1 mole to 1 mole. Okay, this is based on the balanced chemical equation. Then how about based on the question given? If the concentration of the acid is 0.5 mole per dm cube. What is this? This is concentration. Okay, concentration of acid given. How about the number of mole? We don't know. But there is another piece of information given. 50 cm cube of dilute sulfuric acid. So if you multiply these two numbers, if you change this cm cube to dm cube, and then you multiply this and this, mole per dm cube times dm cube, you will get mole. Okay, so the first thing is you have to convert this to dm cube. So 50, so this one we leave it, so this one we leave it here first. So 50 cm cube is how many dm cube? That would be 50 divided by 1000. That would be 0.05 dm cube. Then after that, we can find out the number of mole of sulfuric acid H2SO4, which is the concentration 0.5 mole per dm cube multiply, okay, 0.5 mole per dm cube multiply what? Multiply, okay, can't see in the camera, multiply 0.05 dm cube. You can see that the unit cancel off nicely. Okay, 0.5 mole per dm cube times 0.05. Let me take out my calculator. 0.5 times 0.05, that would give you 0.025 mole, because what is left here is mole. So 0.025 mole sulfuric acid. So that means in the reaction, 0.025 mole of sulfuric acid is used. So at the top here, you have to write 0.025 mole of sulfuric acid. Now this working is extremely important. Usually this working will carry some mark, at least 1 mark. That's why you have to show this. Don't use a calculator and punch, then after that straight away write 0.025 mole here. You have to show the working. So 0.025 mole sulfuric acid. So based on the mole ratio of 1 mole to 1 mole, if 0.025 mole of sulfuric acid is used, that means you would need 0.025 mole of copper 2 carbonate. Now what does the question want? Determine the mass of copper 2 carbonate reacted, not the mole. But from the mole, we can find out the mass. Therefore, you can continue. Mass of CuCO3, that will be 0.025 mole, which is from here, times the MR of copper 2 carbonate, which is 64 plus 12 plus 48, and that would give you 3.1. Okay, let me check. Is it 3.1? Yes, 3.1. Now it's better to give your answer to 3SF, which is 3.10 gram, and that will be the answer. Okay, just a recap. You have to first thing is, for typical mole concept question, you have to identify the 2 substances in the question. Based on the chemical equation, write down the mole ratio. Then after that, find out the number of mole of the substances based on the question. In this case, it involves the use of concentration. So concentration mole per dm cube multiplied by the volume will give you the number of mole. And then from the number of mole, based on the mole ratio, figure out what is the number of mole for copper 2 carbonate. And then from the number of mole of copper 2 carbonate, you can find out the mass by multiplying it with the MR. Okay, let's look at number 2. The diagram below shows 2 different structures of metallic substances A and B. Which metallic substance A or B would melt at a fixed temperature? So this is a mixture, this is a pure substance. So you should know that pure substance melt at a fixed temperature. Okay, because it is a pure substance. Now, which metallic substance is more suitable to be used for making the structures of bridges and buildings? This is a pure metal. So pure metal, they tend to be soft compared to alloy. So the explanation part would be exactly the same as the mind map, which means that you have to explain the structure of alloy. You have to compare and contrast the structure of alloy and pure metal. Okay, which means that this part of this is the metals mind map. This part, why alloy is stronger than pure metal. Alright, so I don't think I need to go into detail. Okay, how about for part B? The diagram below shows an experiment to investigate reactions between metals and metal oxide. Metal and metal oxide. First one is, why is a fuse used in this experiment? Now this fuse and the fuse in physics, in practical electricity, is different. Now this fuse here basically is like the fuse of the fireworks. So it is so that we can light it up and the fire would go into the chemical and that would start the reaction. Okay, so it is to provide heat to start the reaction. Place these 4 metals in order of reactivity, starting with the most reactive metal first. Now, this one is metal and metal oxide. So metal, oxide of P. So based on this, what it means is that reaction takes place. So based on this, is actually S plus PO, which is an oxide of P. Now it could be P2O or PO3 or whatever. That is not important. Now the important thing is when S react with PO, you get, there is reaction, means that you get SO plus P. So the S, the metal S, actually displaces P from PO, meaning that S is more reactive than P. So this S, more reactive than P, more reactive than Q, more reactive than R. Okay, so S is the most reactive. And then followed by, so the number of ticks means that the more the number of ticks means that it is more, means that the metal is more reactive. So this is the most reactive. 3 ticks, most reactive, followed by 2 ticks. So 2 ticks would be P. Then followed by 1 tick. 1 tick would be R. Followed by no tick. No tick would be Q. So it's SPRQ. Okay, place these 4 metals in order of reactivity. Now both Q and R have 2 valence electrons, meaning that they are from group 2. Meaning that Q and R would form ion of 2+ charge. Write a balanced chemical equation for the reaction between R and oxide of Q. So R, oxide of Q, means QO. Because Q is 2+, 2 valence electron, and O you know is 2-. So 2+, 2-, just nice, QO. Balanced chemical equation for the reaction between R and oxide of Q. And we know that R is more reactive than Q, so you get RO plus Q. Okay? And that would be the answer. And state symbol is not required because the question doesn't say state symbol. Alright? Now, metal P does not react with cold water. It reacts with steam at a moderate speed only. Suggest the name of metal P. Now, actually, there's something wrong with this question. This T here is actually aluminium. Suggest the name of metal P. P doesn't react with water. Reacts with steam at a moderate speed. Doesn't react with water. Calcium is the last metal that react with water. And then it reacts moderately with steam. Iron is the last metal that react with steam. Okay, so moderately, very likely it's going to be either zinc or magnesium. Either zinc or magnesium, because magnesium also doesn't react with cold water. And magnesium with acid is also moderate. Well, moderate magnesium is actually violent, so very likely it's going to be zinc. Okay, so the answer should be zinc. A mixture of aluminium and oxide of P were ignited using the fuse to produce P and oxide of aluminium, which means that you have a mixture of aluminium plus oxide of P, PO. And then after that, you will produce P and oxide of aluminium, Al2O3. So it's like that. So that means aluminium is more reactive than the substance. So for this part, it confirms that the substance must be aluminium, because aluminium is more reactive than P. So P is definitely zinc. Aluminium is here. Okay, write the balanced chemical equation for the reaction using the metal name in P. So the P is zinc, right? So it should be Al plus ZnO. Zn is 2+, so it's ZnO. Then after that, you should get Zn plus Al2O3, because aluminium is 3+, O is O2-. So if you cross multiply, you get Al2O3. Then after that, you can balance the chemical equation. How do you balance? You put a 2 here, and then you put a 3, okay? Now what would happen when the oxide of aluminium is added to acids and alkali? Now oxides of aluminium, that means aluminium oxide. So you have to recall from your acid bases chapter, aluminium oxide is a what? It's an amphoteric oxide. Amphoteric oxide, what are the properties? Again from, I think, page 3 of the acid bases mind map. Amphoteric oxides react with both acids and alkali to form salt and water. Okay, therefore, what would happen? That means a salt solution would be produced. Okay, because amphoteric oxide, remember, amphoteric oxide, zinc oxide, and lead-2 oxide. These three are amphoteric oxide.